Welcome to this video on geometric sequences. In the first one here, we notice that it's a geometric sequence because we have to multiply by a common number known as a common ratio to get from one number to the next. In this case, we're multiplying by 3 each time we move through the sequence. Okay, so what I do is I start by working out 3 to the n. Okay, because we're multiplying by 3 to the power of n, and n is the position in the sequence. So here n is 1, here n is 2, here n is 3, and so on. Okay, so when I start with 1, n is 1, 3 to the power 1 is 3, 3 to the power 2 is 9, 3 to the power 3 is 27. I don't need to go any further because what I need to look at now is what am I doing to the number here in blue to get the one above it in our sequence. And you can see hopefully that I'm finding 2/3 of it. 2/3 of 3 is 2, 2/3 of 9 is 6, 2/3 of 27 is 18. So I could write my rule simply as 2/3 of 3 to the n. Okay, 2/3 of 3 to the n. Okay, now I tend to write it like that. Okay, when it's an integer, 3 to the n like that. Okay, and that's true. That is the answer to the question. I could instead write it like this. I could say, well, I don't really want a fraction in front. So if I multiply the whole of that by 3, okay, I will get rid of the thirds and I'll just have 2. And because I've multiplied every term by 3, I now need to compensate for that by reducing the power by 1. So instead of having 3 to the n, I have 3 to the power of n minus 1 like that. Okay, and that's normally how we would present the answer. Any of those two answers are correct. I could, if I wanted to, multiply by 3 again and begin with 6. And if I did that, I would have to change the power to n minus 2. Okay, but we wouldn't normally do that. There would be no reason to write it in that form. But mathematically, those three things are equivalent. So either of those first two are likely to be the answer that you would give for that question. Okay, the next one concerns a sequence that's changing by a multiple of 5 each time. Okay, but this time we're actually dividing by 5. So we're dividing by 5 to get 50, dividing by 5 to get 10, and so on. Now, when you divide by 5, you're also multiplying by a fifth. So if I were to do a fifth to the power of n, okay, 1/5 to the power of n, okay, that's what I'll work out on this line. 1/5 to the power of 1 is just 1/5. 1/5 squared is 1/25. 1/5 cubed is 1/125, and so on. Okay, now to get from the blue number to the number above in the sequence, I've got to multiply by 5 first of all to get that up to 1, and then another 250. So that's 1250 or 1250. So the rule for this sequence is actually 1250 times 1/5, okay, to the power of n. Okay, and that's how I would leave the answer. Now the next one is going up by multiplying by 4 each time. Okay, because 4 times 1/32 is an eighth, 4 times an eighth is a half, 4 times a half is 2. So it's quite easy to see what the common ratio is. So let's work out 4 to the n in the same way we've done the others and see what that gives us. Well, 4 to the 1 is 4, 4 squared is 16, 4 cubed is 64, and so on. Okay, so what do I need to do to 4 to get 1 over 32? Well, I need to divide it by 128, okay, because 4 times 32 is 128. So if you take that number, divide it by 128, it will give me that one. If I took 16 and divided that by 128, it would give me 1/8. So that's what I need to do. So I'm going to write it like that first of all, as 1 over 128 times 4 to the n. Okay, now mathematically that's correct. That is a rule for that sequence. But I could say, well, I don't really want this fraction here, so I'm going to multiply that by 4 to give me 1 over 32. Okay, and that's a smaller fraction, or rather a larger fraction, but a smaller number on the denominator. But then it would have to be 4 to the power of n minus 1. Okay, and then I'm thinking, well, if I'm going to do that, why don't I make it 4 times bigger again? So I would have 1/8, okay, of 4 to the n minus 2. Okay, that would make the fraction closer to 1, but it's still a fraction. So the next step would be to take it to 1/2. In other words, I'm timesing 1/8 by 4 and having 4 to the n minus 3. Okay, but while I've got to that step, I might as well go one more, times that by 4 again, and that will give me 2, which is now no longer a fraction, but then it would have to be 4 to the power of n minus 4 to compensate. So all of those are mathematically correct, and that one at the end is probably the one I would give as my answer now that I've worked it out. But that one at the front would be a perfectly acceptable answer too. Okay, and the next one. Now this is requiring a little bit more care because we've got an 8 going up to a 12, so it's not immediately obvious, but actually what you're doing is you're multiplying by 1.5, okay, 1.5. Now let's look at this as 3 over 2, okay, so 1.5 is the fraction 3 over 2, okay, so I'm going to write it as 3 over 2. Okay, and I'm going to do 3 over 2 to the power of n in the same way that I've done the others. And it's easier to do a fraction to a power than it is a decimal because you can do the numerator and denominator. Okay, so 3 over 2 to the power of 1 is just simply 3 over 2. 3 over 2 squared is 9 over 4. Simply squaring the numerator and denominator. 3 over 2 cubed is 27 over 8. Okay, so that's quite easy to do. And now we have to look carefully at how we get from the blue number to the black number above. Now, just if you consider that carefully, what do I need to times 1.5 by to get 8? Well, it's 5, which would give me 7.5, 5 times 1.5, plus 1/3 of that. So it's 5 1/3, or 16/3. So let me just show you that here. Okay, I'll just write that here. So 16/3, which is 5 1/3, times by 3 over 2. Okay, if you look at that, multiply those two fractions together, the 3's cancel, 16 over 2 does indeed give you 8. Okay, so the sequence I have is 16/3 of 3 over 2 to the n. Okay, so my initial answer would be 16/3 of 3 over 2 to the power of n. Okay, now to change that to something which doesn't have a fraction here, I need to be careful. I don't just multiply it by 3. I need to multiply it by what's in this bracket here, which is 3 over 2. So if I take 16/3 and multiply that by 3 over 2, I would get 8. Okay, and that means that the 3 over 2 would have to be written as 3 over 2, instead of 3 over 2 to the n, as 3 over 2 to the n minus 1. Now notice when I have a fraction, I'm putting the power outside the bracket because that has to apply to the whole fraction. Okay, in these cases up here, I could have put the n outside the bracket. It wouldn't have mattered. Okay, right, so that's the answer I would give for that one, either of those two there. And now we come to the last one. Okay, now this is a negative numbers sequence, and it's going down. And I do the same kind of thing. I just say, what am I having to do to each number to get to the next one? Well, I'm multiplying minus 3 by 1 1/3 to get minus 4, or I'm multiplying it by 4/3. So if I write down the sequence here, 4/3, let's have a look, 4/3 to the power 1 is 4/3. Okay, 4/3 squared is 16 over 9. Okay, and 4/3 cubed and so on would be 64 over 27. That would be 4/3 cubed. Okay, now I don't need to keep writing these down. I can just look at I don't even need to write any of these down. I can just look at the first pair of numbers and simply say, right, what have I had to do to 4/3 to get minus 3? Okay, so what have I had to do to the number 4/3 to get minus 3? Okay, well, minus 3 is minus 9/3. So what have I had to get done to 4 to get minus 9? And I've had to multiply it by 2 1/4. Okay, or minus 2 1/4. Okay, so I'll just show you that here. So if I took 4/3 and multiplied it by minus 2 1/4, which is minus 9/4, you can see that that would give me minus 3, because the 4's would cancel, the minus 9 would cancel with the 3 to give me minus 3. Okay, so in other words, I've got to take the sequence 4/3 to the n and multiply it by minus 9/4. So my rule would be minus 9/4 of 4/3 to the power of n. Now that's a particularly tricky sequence, and it's unlikely you would get anything like that in a GCSE paper. Okay, if I wanted to change that to an n minus 1, I would need to multiply this by I'd need to multiply this by 4/3. Okay, and if I did that, that would give me 4/3 times minus 9/4 would give me minus 3. So the alternative way of writing it would be minus 3. Okay, and that would then be 4/3 to the n minus 1, which is definitely a better way of writing it. Okay, but as I said, that's a particularly tricky question, and it's unlikely you would get anything as difficult as that in a GCSE paper. Okay, so I hope that has clarified how to find the nth term rule for geometric sequences. So if I wanted to get the next term, I would use that rule to find the next term. So if I wanted to get, say, the next term for this sequence here, okay, which is this one here missing, I would simply put n as 5 because I want the fifth term, and I would do 8 times 3 over 2 to the power of 5 minus 1, which is 8 times 3 over 2 to the power 4. And if you check that out, you get 40.5, okay, for the fifth term of that sequence. But you can also see that if you multiply 27 by 1.5, that will give you 40.5, as you would expect. Okay, so that's the end of that video on geometric sequences. Thank you for watching.